Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problems for GMAT out of this book here, the GMAT Review, the official guide. If you do not own this book already, purchase one immediately. You will find it at mba.com. Let's turn to page number 180. The problem that I'm about to solve is the one that you will find on page number 180, problem solving number 205. Let's take a look at it. I already set up the table here to save a little bit of time. So we have three jars, P, Q, and R. We're calling those jars P, Q, and R. And in each of the jars, we have some marbles, red or green marbles. In jar P, we have X red marbles, Y green marbles, for a total of 80. In jar Q, we have Y red marbles and Z green marbles for a total of 120. And in jar R, we have X number of red marbles and Z green marbles, Z, or for those of you who are watching outside the US, Z marbles, or Z green marbles. And the question simply is, what is the question? What is the number of green marbles in jar R? What is the number of green marbles in jar R? We have to find Z if you want. We have to solve for this variable. Now the only way, well, I shouldn't really say only way, you could do trial and error here by picking one of the answer choices and putting it back in there and playing with it, but that approach will probably take you forever here. This is not a good approach here. There are some problems where the classical way is the only way to go about it in the real exam, only way in the sense that that's the smartest way to go about it in the exam. This unfortunately is one of those questions. The classical way is the smartest way because that will take you the least amount of time. But then again, having said that, you have to know the classical way. The classical way I'm talking about here is something called, now I should have looked it up before because I really don't know how to spell the bloody word. So, I think that's how you spell it, simultaneous. These are simultaneous equations. We have three simultaneous equations with three unknowns, and therefore we should be able to solve for all of these three unknowns. The first equation that we have is x plus y equals 80. Let me write that down here. X plus y equals 80. The second equation that we have is y plus z equals 120. Y plus z equals 120. Notice how I wrote them in a reverse order. It's y plus z, but I wrote it as z plus y so that I can put y underneath the y. Now what do you notice right away? What I notice is that if I were to subtract one equation from the other, I can get rid of the y. Once I get rid of the y, then I will have the equation of x and z, and then I have another equation here, x and z, and I can solve for z again. I can subtract. We'll see what happens. So let's subtract this second equation here, the bottom equation, from the top one. So this is plus becomes minus, this plus becomes minus, and then this plus positive 120 becomes a negative 120. And on the top I have the 80. Let me write down the 80 again. That's it. Of course, in the real exam, I'm not going to be so neat and clean and so picky about my things. But here I do it so that you are easy for you to see. I'm basically subtracting one equation from the other. So when you subtract the equations, you have to change the signs. Whatever is positive becomes negative, so they're all positive, they all become negative. So I end up with y minus z. See, the z was positive, now it becomes negative. Oh, sorry, x minus z, and then y cancel out. Plus y and a negative y will cancel out. And here I end up with a negative 40. You have to keep track of your sign. This positive 120 becomes a negative 120. So 80 plus positive 80 plus a negative 120 will give me negative 40. Now I'm going to use this equation here. This equation is x plus z, let me write it in a different color again. This equation here, x plus z equals 160. X plus z equals positive 160. That's it. Now, if I were to add the two equations, this equation here, let me give this equation a name so we can talk about them. The purple one that I wrote here is the equation 1. Where should I put it? This one was equation 1, which is this equation right here. And then the black one that I wrote here, y plus z right here, is equation number 2, which is this equation right here. And then after I subtracted one from the other, I arrived at a new equation here, and then from that, to that, I'm going to take the third equation, third equation in red here that I have, equation number 3, which is what this equation is. Well, I don't want to confuse people by thinking this is a negative sign. It's not a negative sign. So that's my third equation. Now, if I were to add the two equations, I will end up getting rid of z's. If I add this equation to this equation, let's call it equation 4. If I were to add equation 4 to equation 3, negative z and positive z will cancel each other, and I'll end up with x. That is not what I'm interested in. We are interested in solving for z, because the question is how many green marbles are there in the red jar, jar R. Let's see. What is the number of green marbles in jar R? You see, this is what we are interested in. So instead of adding the two equations, again I'm going to subtract. So this positive x becomes negative x, this positive z becomes negative z, and this positive 160 becomes negative 160. Let's see what happens. If I do that, this positive x and a negative x will drop out. Negative z and a negative z, I end up with 2 times negative z, 2 negative z. And then negative 40 and a negative 160 will give me negative 200. And therefore, z equals positive 100, of course. It cannot be negative, obviously, because there's a number of marbles. How can you have a negative marbles? Answer is D. And that's what it is. If there is anybody out there watching these clips anywhere in the world who knows of how to look at the right answer in this problem without doing this traditional classical work, I would love to learn it. Please send me, post a comment or send me an email and teach me. I would love to learn how to solve this bloody thing without the classical way, because not everybody knows how to set up simultaneous equation. If there is a shortcut, please tell me. I would love, as I said, I would love to learn that shortcut, because I can't think of anything. Classical way in this particular case is unfortunately the only way that I can solve it. Trial and error will probably take forever. Anyway, I hope you found this helpful. If you wish to buy my DVDs where I show you the solutions to all the problems, there are 400 of them altogether, 250 problem solving questions, 150 data sufficiency questions. Or if you wish to hire me for personal private tutoring, face-to-face tutoring, I'm located in the state of Connecticut, but I'm willing to go anywhere as long as we come to an agreement. And I'm also in the process of putting together a solution manual in the form of a book, where I give you the solutions to all the problems in a book form. If you're interested in any of those scenarios, send me an email. Go to my website at www.prep4gmat.com. Send me an email. I will talk. All right? Thank you.